So we're going to look at section 4.8 today, and we're going to continue 4.7 really. This is a continuation of the last section. In 4.7, we solved equations by factoring. We solved higher order equations like polynomials by factoring in the last section. Now we're going to do the same thing, but we're going to apply it to those dreaded word problems. Back to word problems again, okay? So this next test that we have coming up will have word problems. The last test didn't, and it saved a couple of you. There were no word problems in the last one. It made it a little bit simpler. This next test coming up this next Monday will have these word problems on it. And the next section has a few word problems also. Okay, so just get used to that idea. So let's jump right into it, please. Let's start with example number 1. A boat is attempting to fire a missile to the east at a civilization that's located on an island. The path of the projectile follows the following curve. F of x equals negative 6x squared plus 18x plus 24, where x is the horizontal location in miles, and f of x is the height of the missile in yards. So we have two completely different units there. The height is measured in yards. The distance horizontally is measured in miles. If the island is located 6 miles east of the boat, will the missile strike it? Will the missile strike it? So, our question really is, when the missile returns to the ground, is it going to be 6 units to the right of where it started? Is it going to be 6 units to the right of where it started? And if you recall from the last section, whenever we solve these equations, we are getting the x-intercepts. So really we're looking for the x-intercepts here. If we could find the x-intercepts and see if this one starts here and this one is 6 away, it lands on the island. If the boat starts here and it lands after 4 units away, then it doesn't reach the island. If it lands after 6 units, like say 7 units further, it misses the island. It's got to land exactly 6 units or miles to the right. So the question here really is, can we solve this equation? And can we look at the two answers and see if they differ by how much? 6. Our goal is to see if they differ by 6. All right, we'll look at this graphically in a minute, but let's look at solving this first by using analytical skills or algebraic skills. So if we're looking to solve this to find the x-intercepts, we always start by setting y equal to 0. Well, look at the equation. This is what we've got here. This is what we're given. F of x equals that. What's y in this equation? Where's y? Annette? F of x. F of x is y. The y value is f of x. Please remember that. F of x is the height of the missile, or the y value, vertically. So we start by putting a 0 in for f of x. And this is what we have to start. George, what do you notice can come out of every term right away?
6.
Yeah, more specifically. Just make it easier on us. Yeah, I'll take a negative 6 out. Just so that my leading coefficient is now positive, right? Just to make this a positive here. That's the reason I took a negative 6 out. So by taking negative 6 out, we're left with the following equation. This is pretty easy to factor, this equation. Why is it easy to factor? 2 reasons. Reason 1, this is 1 right here. Reason 2, there are 2 numbers that multiply to this and add to this. It works out. It can be factored. What do you get if you factor this? Remember, when factoring, let me pose this question again just to make to jog your memory. What multiplies to this and adds up to this? Again, the question you're asking yourself is, what multiplies to this and adds up to this? Luke?
Negative 4 positive 1.
And let's check to make sure. Negative 4 plus 1 gives me negative 3. That's correct. Negative 4 times 1 gives me negative 4. Correct. Good. Now, Hannah, what does that tell me about my answers? What do I have to do in this case? Or what's the next step? How about? I could even get rid of the 0 if you want. You could jump right into the next part.
So when they multiply, they can multiply with 0. So at least 1 has to be 0 equals 0. So So you can set all into 0.
Good. So if I set negative 6 equal to 0, does that do anything? That's a contradiction, right? That's not true, so that doesn't give us an answer. So although that is a factor, it can't be 0. So this part we don't have to worry about, really. So Hannah reminded us that the zero product property tells us that whenever something multiplies to give you 0, one of the factors, we have 3 factors here, one of the factors could be 0. So if we started by setting the first one equal to 0, that's not true. That can't be equal to 0, so that doesn't help us. But the second factor, 1 equal to 0, gives us 4 as an answer. And the third factor, when set equal to 0, gives us negative 1 as an answer. Those are my 2 answers. So although it seems like, how is this going back to the word problem? Think back to the word problem, what it said. If I were to graph this, here's negative 1. Here's 4. That's where the missile starts and ends. The missile, or the boat in this case, is right here. Here's the boat. Okay? And the boat launches that missile, and it follows this kind of a trajectory. And it lands there. Well, how far from where the boat started away does it land? How far?
6 miles.
Yeah? It should, if the island. It wants to, but how much does it actually land? What's the difference here? How far does it go?
5.
It only goes 5 miles, right? So does it hit the island?
No.
It's 1 mile short of the island. Again, we don't know where the island is. We just know it's 6 miles east of where you started, right? So if you started here at negative 1, it means that the island is right here over at 5. So again, let me put little tick marks in. So there's 1, 2, 3, 4, and there's 5. So sure, it starts at negative 1 and it ends up at positive 4. How far is that distance traveled from negative 1 to 4? That's 5 miles. The island was 6 miles away. So in this case, the missile would not hit the island. It's a mile short of the island based on the x-intercepts. It's hard to picture this problem without having done something like this in physics. So that's why I kind of led you through this, okay? You see what I'm saying? It's hard to visualize, but can you see now that the trajectory is a parabola? We're going to look at parabolas later in the year. These curves, it's called the parabola, that curved arc you see. And the missile gets launched from the boat. And it comes back down, and where does it hit the ground? What's the ground? The ground is the x-axis. The x-axis is ground level, if you think about it. Yeah.
The boat can be number 4 as well, right? Shooting to 1.
Sure, but it said it shot east in this case.
Oh.
So in this case, it has to be negative 1. But it could theoretically be another location, yeah. Yeah. Okay, but the missile traveled east. So we'll say that the boat starts at negative 1, and the missile gets launched, and here's the missile. It's about to impact. Okay, it's about to impact right there, but it's going to miss the island by a mile. Any questions? It's a bit forced, right? That word problem is a bit forced. It's not necessarily a naturally occurring word problem with these, but I wanted to just give you something to start that might be a little bit intriguing, okay, or a little bit interesting. Questions so far? Does this theory make sense? Are we all okay with this from last section, right? Factor and set each factor equal to 0. That's the key here. Factor, set each factor equal to 0. Let's jump second problem then. Read it and give me a let statement or give me some sort of a statement to start. Read it and give me some statements. And obviously you can try this by guess and check. Anybody can do trial and error here, that's fine, but I want you to use algebraic approaches. What could I start with? Go ahead, Max.
Let x minus y equal 5.
Why is Max right? Tristan?
Because they differ by 5.
Differ means?
Like the difference in 1.
Yeah. Differ means difference. Difference means subtraction. Very good. The difference between them is 5. And the second part?
xy equals 84.
All right.
That's a product.
So how many equations do we have, people?
2.
How many unknowns?
2.
So this is called a what? A system of equations. They are not linear in this case, by the way. A system of linear equations occur when x and y are separate. But look at the second equation. See how they're multiplied? This makes it a nonlinear system. This cannot be solved with elimination. Okay? It cannot be solved with elimination. The only method that works here, if not elimination, substitution. So, what do you want to do? Bridge, solve for x or y?
Let me see. I was solving for.
Doesn't matter, you pick.
Solve for x.
Okay, so let's solve for x. Why am I solving the first one for x?
So you can plug it into the second equation.
Yeah, if I solve the second one for x, is that going to be fun? Look at the second equation, everybody. You need to not figure this out, but you need to understand this when you see the problem. This would not be fun to solve for x, because then you've got x equals 84 over y. And then you have to plug in 84 over y into the first equation. And it just gets really messy. You'll get the same answer, but it does get messy. So I would solve the first equation instead, like we did here, and then plug this in for x into the second equation. So you get the quantity 5 plus y times y equals 84. And that's one equation. What do I do with the y?
Distribute
Why am I doing that?
because it's multiplying by that quantity.
Yeah, but how come? What do I want to do eventually, Annette?
You want to move 84 over to make a quadratic.
Very good. Eventually, I want to move the 84 over. And to do that, and to make a quadratic, I need to start by distributing the y value to both terms, giving me 5y plus y squared there. Move the 84 over by subtraction. I'm going to reorder the terms. And now we can go ahead and solve. Again, reorder the y squared and the 5y, please. It makes sense to do that. And then move the 84 over by subtraction. Try and factor this one. What are the factors of negative 84 that also add up to 5? Okay? 12 and 7. 12 times 7 gives me 84. 12 and 7 can give me 5 if I put them in the right way. So which is positive, which is negative? Which is positive, which is negative? 12 is positive and 7 is negative, so I yield a positive 5. For the factors, right? Not for the answers, remember, the factors. So the factors are written. Let's write those out properly. If those are the factors, Yihao, what are the answers right away? Yeah. Okay, it's kind of obvious, right? When the factors themselves are binomials with nothing in front of the y value, that is just the opposite, right? Have you picked up on that by now? If you set this factor equal to 0, it just becomes the opposite. That's all it is. Because there's no term in front of the y to make that any different. So my answer for y is negative 12 or 7. But how many variables did I start with? So I need x, don't I? So what's x in the first case and x in the second case? If y is negative 12, what's x going to be? George, if y is negative 12, what's x?
It's going to be
Negative 7. I would agree with George. This is one answer. Take a look, please. This is one solution set right there. Because what's negative 12 times negative 7, George?
84.
And isn't that what we started with, that xy had to be 84? Remember, your given statement to start was that they differ by 5, and their product is 84. Negative 12 and negative 7, they do differ by 5, and their product is indeed 84. And on this side, if y is 7, what's x going to be? If y is 7, what does x turn out to be? Positive 12. Did this problem specify that the numbers were positive or negative? Did it say? Look back. Doesn't say anything about being positive or negative. So you have two answers here. 7 and 12 is one answer. Right? It's like an ordered pair. 7 and 12 is one answer. And negative 7 and negative 12 is the other answer. Again, one set of numbers is 7 and 12. The other answer is negative 7 and negative 12. There are two answers for this problem because both of those sets of answers have a product of 84, and both of those sets of answers differ by 5. If this were an SAT problem, which is on every single SAT, these kinds of problems are on all of them, where they give you the difference between two numbers and their product, or the sum of two numbers and their product, and you have to solve this way, the SAT would say, there are two positive numbers such that, therefore, giving the answer to only be 7 and 12. You can't have two answers on an SAT where it's multiple choice. Is that clear? So they'll specify. It'll say, two negative numbers are the following, and therefore this will be your answer. Or there are two positive numbers such that, and therefore this will be your answer. Is that clear? But it didn't specify in this problem, so I want you to recognize that there are two sets of answers here. Okay? Questions so far? All right. Let's jump to the one then. We've got a couple of these to do, so I want to make sure we get through them. The beginning few were easier. Let's get to the harder ones. So now we have a little bit of geometry. I know you haven't all taken a lot of geometry yet, but you should know about rectangles, honestly. You should know about rectangles, the area, the perimeter of rectangles you should know, just from like middle school. If you don't know it, it's not a big deal, but make sure you understand it by the end of this example. So the length of a rectangle is a meter less than twice the width. If the area is 55, find the perimeter. So I start these by drawing right away. I draw my rectangle. I'll call the width W. Why would I call the width W? Because now what can I do with the length?
Make an equation that includes W, so it would be 2W minus 1.
Very good. So the the length is 1 less than twice the width. So 2W minus 1. Again, 1 less than means minus 1. Twice the width is a 2W. So I wouldn't even use L here. Normally, you use L for length. I would just go ahead and do exactly what Bridge said and write 2W minus 1 in both of those cases. Now, the area is 55. The area is 55. What can I write as a result then? What can I write if the area is given as 55? Luke, go ahead.
2W minus 1 times W equals 55.
So length times width equals 55. I agree. Length times width. Remember, 2W minus 1 is really length. So if you want it to start like that, that's fine also. And then replace length with 2W minus 1. Yeah? Does that make sense? Okay? If you want it to write less statements and write let L equal 2W minus 1, and then you replace L with 2W minus 1, it's the exact same thing. I'm just using the diagram on the right instead of let statements. Tristan, what do I do next? At this stage, when I'm stuck with 2W minus 1 times W equals 55, how do I solve something like this?
Do you multiply W or no?
That works?
Yeah?
Yeah? And then what?
And then you would divide by 2 double. You take out the wages. I don't know.
How have we been solving all these? By doing what method?
Oh, by factoring.
So what do I have to do with the 55 to start?
Oh, I added to the other side.
Yeah, move it over to the other side. In this case, subtract it. Okay, so that's what our equation looks like as a result. Please remember, please write yourself a note. Whenever you're solving a polynomial, you need to get 0 on one side. Is that clear? You need to always get 0. Why do you have to get 0 on one side? That's what allows you to use the zero product property. That's what allows you to set each factor equal to 0 individually by moving them over. Is this a nice problem? No, it's not. It's really not. We probably want to use AC method. Some of you will probably be able to do this just by looking at it, and you can. Either way you'd like to is fine. I'm going to just show you the AC method again. AC would be 110, negative 110. In this case, B is negative 1. Where does negative 110 come from? 2 times negative 55, that's AC. And then B is whatever's here. And since right here there's a negative, it means that B is negative 1. And remember, I have to ask myself, what multiplies to negative 110 and adds up to negative 1? 11 and 10 work out. Which and which? Which is positive, which is negative, Kate? So we'll say a negative 11 and 10 are the numbers we're going to use. But that's not my answer, remember. With AC method, that's not the answer ever. That's what you break up the middle term into. So leave the first and the third term alone. The middle term gets broken into negative 11w and positive 10w. Remember, whatever factors multiply to AC and add up to B are the two things that you're going to use to break up your middle term. Why do I break up the middle term? What does that allow me to do? When I have four terms, factor by?
You make like the following.
Yeah, what is that called? Factor by?
I forget.
Bridge?
Grouping.
Grouping. Yeah, good, George, though. Grouping. It's called grouping. It's fine. So we go ahead and we split this and we think about this as two parts. I first look at the first two terms. 2w squared minus 11w. What's the GCF? What's the GCF out of 2w squared minus 11w, Max?
Wait, what?
What's the GCF out of the first two terms?
I did it different, but 2, W?
I'd go with just w in this case. You switch the 11 and the 10? That's fine. But in the case we have, it's just w, right?
Well, yeah.
You'll get the same answer, right? What does that leave behind? What is that? Yeah?
W,
Two-
minus
2w minus 11. All right. But by the way, Max put 10w and negative 11w in different spots. That's why he's having the reverse answer when he was doing it. Doesn't matter which way you do it. If I get 2w minus 11 in one parentheses, yeah, I got to have it in the other one. So over here, I know I'm going to have a 2w minus 11 here. What has to come out of that to give me 2w minus 11? Tristan, what do I have to take out of these two here to give me 2w minus 11? A 5. Positive or negative, Tristan?
That would be positive, right? Yeah.
With confidence, right? Yeah. Think about it. You start with positive 10. You want it to be positive 2, so you got to take out a positive. Start with a negative. You want it to still be negative, take out a positive. So that's what we have. So our answer, we take out a 2w minus 11 out of both now, and we're left with w plus 5. So either, it's up to you guys, honestly. Either you go from here, at this line, to AC method and do all this, or you go from here right to here. And some of you I know can do this, that's fine. If you could see from here that the answer has to be a 2w and a w, that's pretty obvious, right? And then if you see 55, the only factors of 55 are either 1 and 55 or 5 and 11. So it kind of limits your choices, right? So you could do trial and error here. If you'd like to go from here right to here, do trial and error, that's fine. Or you can choose AC method, which guarantees that it's right, but it's a little bit more work. Okay, depending upon where you are individually, you take that different route, each of you. Answers are... This one's easy, right? Negative 5 is one of them for sure. And what's the other answer, Hannah? 11 over 2.
I wrote it as negative 5.5.
I wrote it as positive 5.5.
Oh, okay.
Agreed?
Yeah.
Yep. Which one's it? Why? Can you have a negative width? No. Use logic, right? You're finding the width of a rectangle. The width of a rectangle cannot be negative. So the answer is 5.5 for the width. Are you done? Are you done? What does the problem ask you? Ash? Yeah, find the perimeter. This is only the width. If I have the width, I need the length, and then I can find the perimeter. And then I can find the perimeter. If that's the width, what's the length? Luke, what's the length? Quick.
The negative 5 would be...
I don't need it. Reject it. It's negative. Who cares? How about the other one?
Oh, 5.5 to the 10?
10. How do you know that? Because 55 is the area. 55 divided by 10 gives you 5.5. Or you just plug it in. Okay, if you weren't sure, remember this earlier. Earlier we said this. Bridge told us 2w minus 1 was the length, right? So if you take w and plug it in, plug in 5.5 here. Okay, there's the length in case you weren't sure. you want to actually solve for the length, you can do it this way. The length was defined as 2w minus 1, plug in the 5.5, get the length of 10. Well, recognize, when you multiply these two, you get 55. That's the area, 55. But are we asking for the area? No, we're asking for the perimeter. What is perimeter, Max?
31.
31. How'd you get it, Max?
You just count the sides.
Yeah, you got L plus W, giving you, again, in this case, 31. And my units on this case should be meters. Okay, 31 meters. 31 meters. How do we do it? Pretty straightforward? Okay, only reason I go a little slower is because I know it's geometry, so I'm asking those questions because you haven't taken a geometry course officially yet, but I know a lot of you have a lot of background in geometry, so you're fine. 41 or 31? No, 31. 10, 10, 5.5, 5.5. Yeah. Okay, and worst, hey, by the way, another thing that nobody seems to ever do, but in case you wanted to know, you didn't need the length at all. You did not need the length. Once you get W equals 5.5, simply go back to your diagram and plug in 5.5 in all four of these spots, and then add those answers up. Or add these expressions together. 2W plus 2W plus W plus W is 6W. Negative 1 and negative 1 is negative 2. This is the expression for the perimeter. 6W minus 2. Plug in 5.5 there. 6 times 5.5 is going to give you 33. Minus 2 gives you 31. Same answer. Okay, so you really didn't need the length of this problem. The problem never said find the dimensions. It said find the perimeter. So if you want to just plug into these four and add them up, you get the perimeter. That's the perimeter expression right there. Is that clear? Okay, this is the perimeter in terms of the width only, not in terms of the length. Either way works. Okay, either way works. Again, plugging in 5.5 right there gives you a perimeter of 31. All right, let's get to some of the more tricky ones now. Okay, we got two more to go here. Two more. This one's all right. The last one is probably the trickiest. The product of three consecutive integers, three of them, not two now, is 21 more than the cube of the smallest integer. This is vocabulary at this point, right? You see how the vocabulary plays a role? Find the integers. Three consecutive integers. How do I define them with let statements? What should they be written as if they're three consecutive? They're not even integers. They're not odd. They're just consecutive integers. How do I define them with variables? Annette?
So x could be the smallest one,
I would agree with that for sure.
and then you have x plus 1 is the second one, and then x plus 2 is the third one. And then
Now,
you have 5 and 6.
very good. Before I go further, I could have made x the biggest one, but it would get really messy because I have to cube the smallest integer. Look at the actual wording, please. Does everybody see cube of the smallest integer? Would you want to cube something that says x minus 2? Because if x was the biggest integer, this would be x minus 1. This would be x minus 2 for the smallest integer, right? Then you'd have to cube x minus 2. That is really messy. So I would absolutely agree with Annette that you start this way. We know that the product of these three, the product, how do I write product? All right. So there's the product. The product of these three consecutive integers is, what does is mean? Equal to? 21 more than. Tristan, 21 more than.
21 plus
The cube of the smallest?
x cubed.
X cubed. Very good. Everybody see that equation? Does that make sense? You need to take English and translate it to math. Or whatever language you are reading and translate to math. Its own language. Alright? Now, again, just to point out, you would have had x minus 2 cubed over here if you had made x the largest integer. That would have been really messy. It's not worth all that extra work. Take the easier root of them. So x plus 1, x plus 2. I need to multiply all that out, right? It's going to get messy. I'll leave that alone. I'll multiply this out first. Once I multiplied the two binomials out, I can collect terms. And obviously you can go faster than what I'm doing. I'm just showing all the steps. Now what do? Use your intuition to guide you. Remember that you need a 0 on one side eventually, right? You need to get 0 on one side eventually, so you probably want to combine terms and collect terms. But you can't do that just yet. What do you got to do first? I would distribute the x first. I agree. Why is that a convenient thing to do? What did Bridge do by distributing the x? What does he allow us to do now?
Now you have another x cubed on the other side. I think it's easier to bring it to the other side to make it 0.
Yeah. X cubed and x cubed, what happens to them? They both cancel. Subtract x cubed from both sides. Subtract x cubed. Subtract x cubed. Subtract 21. Subtract 21. Those cancel, those cancel. Sure, you get 0 on the right-hand side. That works out. That's what we wanted. X cubed minus x cubed drop off, leaving me behind with 3x squared plus 2x minus 21. So again, just move everything over is what I'm saying. When you move over the x cubed, they drop off. When you move over 21 equals positive, what does it become then? Negative. Remember, when you move something from one side of an equation to the other, just switch the sign. Forget adding and subtracting, honestly. You don't even have to remember that anymore. If you move something from one side to the other, and it's an entire term, just switch the sign. Now what do I have to do? Just like I've been doing for all of the other examples. Yeah, I would go AC method in this case. Okay, I would definitely use AC method. I know it's going to be 3x and x, but well, I shouldn't say that. This is not that bad of one to factor. 21 is either 7 and 3 or 21 and 1, right? It's one of those two. So you could sit here with trial and error and practice it. AC method would tell me that AC is going to be negative 63. B would be 2. What numbers multiply to negative 63 and add up to 2? Hannah, you got it? 9 and negative 7. I agree, it's a 9. 9 and negative 7. So as a result, and I'm gonna go back and just erase this real quick to show AC method. I break up my middle term. This is a good review for the midterm. See this? How we're reviewing AC method, stuff that you did in the past. I break up my middle term into positive 9x and negative 7x, just like what I saw over here. Remember, the 9 goes here with the x on it, the negative 7 goes here. This is what allows me to use grouping. Tristan, what do I take out of the first two?
You would take out 3x.
Leaving me with?
Leaving you with x plus 9.
X
Plus 3, sorry.
That's all right. If that's x plus 3, I know this has to be x plus 3. It has to, right? It has to. Yeehaw, what do I take out to get x plus 3?
7.
Be careful. Negative 7. Okay? Take out negative 7. That's the key here, right? You can take out 7, obviously, but if you take out a negative 7, you're left with x plus 3, which is what you wanted in the first place. So now x plus 3 is in both terms. That comes out front, leaving me with 3x minus 7. So for those of you that did this by just looking at it, make sure you got that answer. That's fine. Okay, if you didn't use AC method, that's totally fine, but make sure you understand your answer is correct or incorrect. You're going to get x equals negative 3 and x equals 7/3. X equals negative 3 and x equals 7/3. Which is your answer? X?
Negative 3.
Why?
It's
Integer. The problem said there are 3 consecutive integers. That is not an integer value, so that is ruled out automatically. So the smallest of the integers is negative 3. So what are all of the integers? If the smallest is negative 3, what's the next one? And then? Negative 1. Okay, this was x. So the next one is x plus 1, which is negative 2. And the next one is x plus 2, which is negative 1. Those are my 3 consecutive integers. And if you don't believe that this is true, what's the product of these 3? Check. What does the product become? Multiply it. Negative 6. What's the cube of the smallest? Here's the smallest, actually. Be careful. This is the smallest. The cube of this? Negative 27. What do negative 6 and negative 27 differ by? 21. And that's what we said in the beginning. They differ by 21. You can always go back to the beginning to check that your answer was correct. Okay, a lot of work for one problem. See how much work that involves? But what's going to happen? As you get more practiced at these problems, they will get easier and they will take you less and less and less time. Are we good? Yeah? All right, last one. Well, we'll talk about this slide. We'll go to the next problem. So I think I mentioned this to you at one point. Projectile motion can be modeled by these two equations. You have two options, one that's in meters and one that's in feet. If the height is given in meters, we have the first equation. It turns out that negative 4.9, that comes about from half of gravity. Gravity is 9.81. You'll see that in physics a lot more. You don't have to memorize these. These will be given to you. But you do not have to memorize these equations. Now, in both cases, V0 represents the initial velocity, and t is time measured in seconds. H is the height. So just keep this slide in mind for the next example. All right? A signal flare. What is a signal flare? Anyone know? Anyone knows boats or anything like that?
Like those things that shoot out like red rockets when you're
Yeah, the little flare guns. If you're like in distress, you need help. They're like in the little safety things on boats. So a signal flare is fired upward from the ground level with an initial speed of 294 meters per second. Meters, meters, meters. So it's the one equation that had 4.9 that you're going to use here right away. A balloonist cruising at a height of 2450 meters sees it pass on the way up. So I need you to visualize. Here's what's happening. Here's the balloonist. Here's the signal flare. Launched. It goes up. What happens after it goes up? It has to come back down. So he sees it on the way up. And it says, how long will it be before the flare passes again on the way down? So if we could find the time it takes to get to here, right? So say it takes 3 seconds, and then we find the time it takes to get back to here, it's 5 seconds. How much time elapsed? 2 seconds. So let's figure out those times. Okay, let's figure out those times. So let's go ahead and model this. Let's take a look at our equation of motion. The equation from the previous slide that was given in meters that we're going to use is the following. How high is the flare when it passes the balloonist? What is the height, h, of the flare when it passes the balloonist? Max, what do you got? Yeah. That's the height of the flare. I can draw my units at this point. When it passes the balloonist. What are we trying to figure out? What are we trying to figure out?
The time.
The time. So let's leave that blank, right? Or leave that unknown. What's the initial velocity? What's the initial velocity or speed of the flare? What do I plug in for V0 there?
294.
Yeah, 294 goes in for V0 there. And now it's just simply a quadratic. I made it work out very nicely. You're going to see in a minute what happens. Move 2450 over. In about a chapter or two, we're going to learn about the quadratic formula, which many of you already know, I know. And we'll go over it. And at that point, I would say, you know what? Use the quadratic formula to solve. But here, you don't have to. It turns out that 4.9, if I'm correct, I think goes into all of these. Try to divide them all by negative 4.9 or 4.9. If I take out negative 4.9, I know that's going to be t squared. I know that's going to be a negative. That's going to be a positive for sure because the signs are going to switch. What are my numbers? What's 294? Right? Take 294 divided by 4.9. George?
Yeah, 60.
60. The middle term is just negative 60t. And then take negative 2450 and divide that by negative 4.9. What does that conveniently become? Annette?
500.
Okay, that conveniently becomes 500. Why do I say conveniently? Because those are integer values, And as a result, I can try and factor these now. The negative 4.9, that hangs out in front. Just like earlier when we had a 6 out in front. Here's what you're going to get, just so you know. So that means that it passes at 50 seconds and at 10 seconds. So how much time has elapsed between those two times? Here's the balloonist right here in the hot air balloon. T equals 10, and then on the way down, T equals 50. How much time has elapsed between 10 and 50? 40 seconds. Make sure to do the homework tonight. It is due tomorrow. Homework tonight is due tomorrow.